What's up, AP Calculus students? If you're looking for the video on cross sections, you found the right place. I hope that through this video you get a better understanding of cross sections and all the problems that come with it. So with that being said, let's get started. So here's a list of a lot of the common shapes you'll see when it comes to cross section problems. So take your time to get familiarized with a lot of these formulas. Alright, so the first thing that you need to know when dealing with cross sections is that when you're given a function, if the cross sections generated are perpendicular to the x-axis, then their areas will be functions of x. And likewise, if the cross sections are perpendicular to the y-axis, then their areas will be functions of y. So the easiest way to understand cross sections better is to just go ahead and do a problem. So the first problem, it reads, find the volume of the solid whose base is the region inside the circle x squared plus y squared equals 9 if cross sections taken perpendicular to the y-axis are squares. So the first thing we got to remember is that because the cross sections are squares perpendicular to the y-axis, the area of each cross section should be expressed as a function of y. So right here we have the graph right here. We have the function x squared plus y squared equals 9, this circle. And the side of the square is perpendicular to the y-axis. So we got to remember, we got to make it function of y. So we got to find the area of the square. The area of the square is just side squared. So we need to find the side. So if we use this function up here, we could find that this part right here, half of the side of the square, is square root of 9 minus y squared. And all we have to do is just multiply that by 2 to find the full length of the square, which is 2 times the square root of 9 minus y squared. So the area of a square can be found by multiplying one side to the other. So right here we could see area equals side squared. And to find the volume, we just have to find the antiderivative of the area. So here we have volume equals the antiderivative of the area, which is side squared, and all in respects to y. And so if we plug in the side here, it'll be volume equals the antiderivative from -3 to 3 of 2 times the square root of 9 minus y squared, all squared dy. Now, since we plugged that in, we could just obviously square this whole thing, and it would be antiderivative of 4 times 9 minus y squared dy. So now that everything's set up, all we have to do is now take the antiderivative of the area. So to take the antiderivative of the area, you would get this right here, and all we have to do is plug in 3, which would give you 18, and subtract -3, which would give you -18. And don't forget to multiply by 4, and you would get, as your answer, volume equals 144. So for our next problem, the problem reads, find the volume of the solid whose base is the region bounded by the lines x plus 4y equals 4, x equals 0, and y equals 0 if the cross sections taken perpendicular to the x-axis are semicircles. Now, first things first, we gotta remember that because the cross sections are semicircles perpendicular to the x-axis now, the area of each cross section should be expressed as a function of x. So this is the function right here. This line right here represents x plus 4y equals 4. To find the area of a semicircle, we just gotta multiply 1/2 by pi r squared. So area equals 1/2 pi r squared. So we gotta remember that because we're limited by x plus 4y equals 4, x equals 0, and x equals y, we're working with this little area right here. So first things first, we gotta find the diameter, and the diameter of this is 4 minus x over 4. You could find that using this function right here on the top. And the radius of that is you just have to multiply 1/2. So if you multiply 1/2, the radius is 4 minus x over 8. So now that we know the radius, we just have to plug in the radius to the area formula to find the area. So the area formula, once again, it's 1/2 pi r squared. So if we plug in the radius, that would be 1/2 pi times the quantity of 4 minus x over 8 squared. And that would give us 1 over 128 times pi times the quantity of 4 minus x squared. And to find the volume, all we have to do is take the antiderivative of the area. So right here we have volume equals the antiderivative from 0 to 4 of the area, which is 1 over 128 times pi times the quantity of 4 minus x squared. And we got to remember that this problem, it's in the d of x. Alright, now that we have everything set up, all we have to do is go ahead and take the antiderivative. So the antiderivative of the area is given right here. That's the area. So first things first, we got to take 1 over 128 pi outside and find the antiderivative of this part. The antiderivative would be 16x minus 4x squared plus 1/3 x cubed. And if we plug in the 4, that would give us 64 over 3. Minus, we plug in the 0, which would give us 0. And make sure to multiply 1 over 128 pi by the 64 over 3. And your answer would be pi over 6. So there will be problems where the problem gives you two functions and you would have to use the area in between the two for your cross sections. Now some of them may seem intimidating at first, but do not fear because they're actually quite simple. So this is a little example I thought of right here. And so y equals x squared, that's this right here, and y equals 1, that's right here. So we've got to use this area in between right here for our problem. So let's say that we're talking semicircles. The area of semicircles is 1/2 pi r squared. So if we go ahead and just plug in everything right here to find the volume, it would be the same thing as before, 1/2 pi, the antiderivative of, in this case, negative 1 to 1. And all we have to do here is just take the top function, so in this case it's 1, minus the bottom function, which is x squared. And yeah, you just use that to go ahead and find your volume. Alright, so that's pretty much it from me. I hope you guys got to understand and learn a little more about cross sections. If you guys are looking for more practice, you could always head over to the worksheet I made. There'll be a couple of problems there for you. But for now, I wish you all luck on your future endeavors, and catch you guys later. Peace out.